Hello everyone, welcome to this video. I am Vishal, and in this video I'll be showing you how you can decrease the number of draw calls of your scene in your Unity game. So let's get started. You can see that we have got a scene here with bunch of objects, and each of those objects are a separate mesh. And now if we run this game, there's nothing in this game actually, just on those objects. If we run this game and open a profiler and go to rendering, we can see that the number of draw calls is 115, which is really high if you are aiming for a mobile device, because mobile devices can sustain up to, if it is a very good mobile, 120 draw calls. But if most of the mobiles that are in the market which are not very high end and doesn't have a GPU core, maybe they can sustain only up to 20 to 50 draw calls. So what is the idea here is that we have put all those objects with uh, mesh each in under a single root game object, and from in this game object we will write this script draw call optimizer, and we'll take up all these meshes and merge them into a single mesh altogether, and we'll keep that only in the scene and remove these meshes from the scene, and we'll see that how low can I get with that optimization technique. And okay, so let's get started. Okay, now first of all we would need a empty game object where we would put the final combined mesh, and we would link it to the mesh filter. So we would call it public game object empty prefab, maybe. Or let's say empty combined prefab. Oh, I did spell it wrong, right? Oh, empty combined prefab, and let's open up Unity. And I have already created a prefab here. I will show you what it is. So this prefab has a mesh filter and a mesh renderer. Mesh filter is required because we would link the new combined mesh that we create from the script to this mesh filter component, and the mesh renderer will be rendering the mesh itself. So we don't need it here, so delete it. And in the script, attach the combined game object. So now if we go back to here, uh, we'll be doing all this stuff in start method itself. So So first of all, we need to get the mesh components or mesh filter components of the children, from where we'll be accessing the mesh, and we'll be taking out the mesh data of vertices, triangles, and the UV coordinates, and we'll be merging them onto a new combined mesh. So let's get the transforms of those children first. Now once we have get all the children, you can directly access the mesh, you can directly get the mesh filters just by calling get component mesh filter. But this list of transforms can contain also those transforms which doesn't have a mesh filter. So in my scene I don't have any transforms right now, so though it will work. But if you have maybe say if you have created using two models, you have created a single prefab, so the root of the transform, so sorry, the root transform of these two objects will not have any mesh filter component, but it will come in that list of children. So what you need to do, we will create a list of transforms, and we'll call transforms list, nothing else. So and assign it to a new list. And now we'll go through the children one by one and check if it has got a mesh filter component. So say int I equal to 0, I plus plus, and then we say mesh filter m equal to children I dot game object or directly you can say get component mesh filters. Now we check if it is null. If it is not equal to null, then we add this transform to our new transforms list. Dot add children I. And once that is done, and now once we have got the transforms list, we would also need the list of meshes that we have. So let's create another list. Let's call this message equal to new messes, and we add this mesh, sorry, to the list. So we do name.mesh. Okay, so now once we have got all the meshes, we need to write a function. We should merge those meshes. So let's call this void, or let's return the combined message from that function called merge meshes. We would give it a reference of mesh filter. It should be the mesh filter of the combined game object mf, and also the list of the meshes. Now this combined mesh object would be the one where we'll be filling in the vertices and the triangles out of the individual meshes, and after return combined mesh. Now first of all, what we have to do is that we have to count the total number of vertices and triangles that are there in the original meshes, and we have to assign the vertices array and the triangles array in the combined mesh object. So we would have to go through all the meshes in the list. So create a for loop, say meshes dot sorry sequence dot count I plus plus, and here we access mesh m meshes I. Okay, now we will be needing to counter variables, so let's call vert count equals 0 and try count equals 0. Now when here what we do is that we say vert count plus equals m dot vertices or vertex count. Okay, now in try count we say m dot triangles dot, sorry, just length. Yep, we count m dot triangles dot length. Okay, now vertices would be a vector 3 array, as it contains the coordinates of the points or vertices in the mesh. So let's call this vertices equals new vector 3 array of size vert count, and we create another array. This will be vector 3, this will be int, this will be called triangles, and this will be int down here, and well, triangle count, sorry, try count. Now we'll also need another array for storing the UV coordinates, and UV coordinates are vector 2 objects. So it contains basically the coordinate of the point in the texture, like which point in the texture the vertex correspond to, and since each vertex will have a UV coordinate, the size would be same as vert count. So this would be vector 2 vert count. Alright, So now once we have this, we'll have a running another for loop same as this one, and we'll be copying the mesh is into the final array, final mesh. So we don't need these two lines. Okay, now once you're here, we'll be calling a function something like this, copy this one. We'll be creating this function, so this would be something like copy vector 2. Where to copy, we'd have to give the reference of the array, so that would be vertices, and we would have to give the source of the array, that would be m dot vertices, and also we'll have to we need to tell the function that from where it should start copying. Or what I meant to say is that it will be copying the whole m dot vertices array into vertices array, but it will not start from the 0th index in the vertices array. It will be starting until where it has already been filled. So we need another variable for that. So it would be vert current size 0, and this one would be try current size. So this would be vert current size, and we need to copy the number of vertices that are in the mesh. So m dot vertex count. Uh, okay, now let's create this copy function, or let's just write down the prototype of the function so that it stops giving the error. So this would be a generic function, so we would need a template for this. So we'll call that t, and we would be taking a reference of the destination. Let's call this dest, and we would be needing a source array too. So this would be source, and then int the start index in the destination and the size of what do you want to copy, the size of the array. Okay, now once you've done that, we'll be needing to do the same thing for the triangles array too. So vector 2, this will be triangles, this will be m dot triangles, this would be try current size, and this would be m dot triangles dot count, or sorry, length. Okay, so we would be also, wait, why is it giving error? Oh wait, sorry, this is a int. Okay, now we need to increment the word counts. So this would be word count plus equal m dot meshes, m dot mesh. What? Oh, sorry, m is the mesh itself. So m dot, sorry about that, m dot vertex count, and we need to increment the try count also. Oh, my bad. This is not the word count. This is word current size. This is the variable that is keeping track of the location that I have already filled. So this will be try current size, yep, plus equal to m dot triangles dot length. Yes. Okay. Now, one thing that will be a problem here with the code that we have written is that we are directly assigning the triangle indexes that were in the original mesh if we are copying it this way, because since we are concatenating the vertices of the different meshes into a final vertex array, so the index that of the vertices that were in the original mesh are not the index in the combined mesh right now. So we would have to add an offset to this triangles array. So we can do one thing, that for copying that way you can write a different copy function, or what I will do, I will use something called delegates. So what it allows is that I can add a callback function here, not a callback function, I will define an inline function here which will be called on each of the elements that we are copying to the array. So if you don't get it, you will see it in a minute. So just let me create a delegate. Delegate says the what the prototype should look like of the function. So let's define a delegate. This delegate would return a type t, and let's call this delegate action, since we need to do this on each of the elements in array. And it takes item of type t. So there goes our delegate prototype. And once you have done that, add action in here, action, and this will be of type t, and we'll call this action. Okay, now once you've done that, we'll define a inline function. Sorry, not this one. Okay, now we can add our callback function, or sorry, inline function here. So we do that by writing delegate, and then we mention the name of the parameter that we want to pass. Sorry, this would be int, since this is an int array. So let's call this int k, and here we define the action. So it should return k plus offset that we will be defining soon. Okay, so what offset would be int offset, or sorry, we already have offset. This would simply be the vertex current size, because the 0th index of mesh starts from the location where we have ended in the last iteration. So it will simply be the vert current size. So just copy that. Okay, so what it will do, we haven't written the function yet, but it will basically do is that with each element that we have in here, it will add the vert current size to it and return and put that in the final destination array. Okay, so let's start writing the copy function. I will finish that and then we'll continue with the combine merge. We first check if none of the references that was sent are null, and if they are null, we did put error in the console. Send that null reference error. Okay, so and we return from the function so that it doesn't continue anymore. Now we want to put the elements one by one from the source array to the destination array. So let's start writing a for loop. So int I, and we'll be starting from the index test start. We call this this must be less than test start plus size and I plus plus. Now here what to do is we write test I equal to source. Okay, now we can't use I here because I is the array index for the destination array, but it is not for source. The source would be starting from 0. So just not offset, let's call it j. Okay, so we put source j into the destination, and we also need to increment j. Now we apply the delegate function that we created onto this source by calling action just like a function. So by calling action source. Okay, so that's it for the copy function right now, I suppose. Okay, if there is any problem, we'll check it later. Okay, now in the word count, we don't have any action, so we need to pass on null, or we can check it here itself. Let's define a default variable, default value for the action. Okay, in that case, we'll have to write another loop if in case action isn't passed. So let's check if action is null. If it is null, then we call a different version of the for loop. Otherwise we call this version. If it is null, we just simply put the element in the source array. Okay, now once you have done that, we should have our mesh ready. So let's assign the first okay, so let's assign the mesh that we created to combine mesh. So we do that by saying combine mesh dot vertices equal to the vertices local vertices array, then combined mesh dot triangles equal to triangles array that we created, and then we return combined mesh. Now once we have got the combined mesh here, so let's call the function. So mesh combined mesh equal to merge meshes, and this would be okay. We first need to instantiate the prefab first. How do we attach it? So let's call it game object geo equal to instantiate empty combined prefab vector3.0 and quaternion dot quaternion dot identity, and cast is it as a game object. Okay, so now once I've done that, we need to get a reference to the mesh filter. Mesh filter mf equal to geo dot get component mesh filter. Now we pass on the reference of mf and the list of meshes, so that is message itself. Okay, now we forgot to do one thing in the merge meshes function. We have to assign this mesh to the mesh filter that we have passed. So mf dot mesh equal to combine mesh. Okay, let's go ahead and try to run this function and let's see what happens. Okay, so we have the prefab here, so let's call it, and well, I can see something pink out there. I don't know what it is. Okay, oh wait, well, there is some problem in the script, but we first need to assign a material to it first. Okay, let's create a material here. First create a folder mat and create a material, call it default whatever mat, make it mobile diffuser, let's leave it with standard. So, and okay, fine. So now in the prefab we need to add this material. Okay, and we need to check if it is attached to the render. Yes, now we run this again and we'll see what is happening. Okay, all the meshes are probably the same location. Oh my god, is it, or is it just a single building? I don't see anything. Yeah, I think, wait, we can check that by checking it here. Yeah, it has got everything in a same location. So let's check what is the problem. Okay, yes, right now here we are uh, attaching the adding the vertices from the mesh directly to the vertices array. Now these coordinates in the mesh dot vertices are local to the object's pivot that was there when I created the model in the 3D application. So what we need to do, we will have to transform this mesh dot each vertices in the mesh dot vertices array to the world space. Okay, we can do that by calling a function called transform dot transform point. What it does is that it takes a local coordinate of a point and it transforms it to its world position that should be. depending on the root location of the object. So what we can do, we will need the list of the transforms of the objects. So let's add the children's array. Let's pass on the children's array to it. Children. Wait, not children. This should be transforms list. Okay. Now once we have got that, in here we can get the transform root of the mesh that we are copying from. So it will be transform t equal to children's I. Okay, now once we have got that, we define another delegate action here. So it will be delegate, it will be taking in a vector 3 v, and what it will be doing, it will be doing t dot transform point. Okay, what it does, transform position from local space into wall space. Yes, that is what you want. So t dot transform point and put v. Yes, that's it. We need to return it. Okay, so let's see what happens after that. Okay, if we run the game again, well, it looks like it has worked. So if we go to combined object and take that up, yes, you can see that we have successfully created a copy of all the meshes that are there in the scene into a single mesh. Okay, so let's check how many vertices we have got. It must be the same as before. Yeah, it is 13k. So that is in the safe bound, because Unity has a bound of 65k for 65k vertices for each models. So there is no problem in rendering now. Okay, so one thing notice there that uh, one problem is there though, is that if we take that up, as you can see that all these meshes looks like just like that, they are a 2D out of a 2D image, 2D flat image. That is happening because we haven't assigned the normals to the objects, to the vertices. So we can do that by copying the normals array itself, or also we can call a function that is there in the mesh API, in the mesh class. So we do that by calling combined mesh dot recalculate normals, and once we do that, the object should look all right. So okay, now as you can see that now they look as they should be. Okay, so if we, let's try changing the color. Actually, white doesn't look good. Okay, so if we put a green shade, yeah, now that looks good to me. Okay, so once you have done that, okay, so once we have finished doing that, now let's remove these meshes from the scene. To do that, what you can do is we can simply, let's just deactivate those transforms that we collected from this. So let's call for int I equals 0, I less than transform, or wait, let's just copy it from here. Okay, so this would be transforms list, and then okay, what we want to do is, here is it, oh, what happened, okay, this is dot count. Okay, so we want to do transforms list I dot set active, or sorry, game object dot set active false. So now once you have done that, this original object should disappear. Well, so you can see that now we have only one mesh that we created in here. So script is working all right. Okay, now let's test the number of draw calls we right now have. Okay, so start. Okay, first of all, let's disable the script and run it. And we can see that there are 115 draw calls right now with the script disabled. And now if we enable the script and run the game again, and well, you can see that we have downsized the number of draw calls to 13. So well, that's a really good optimization. Well, now you must be thinking that what happens to the texture that we are having in these original models. Okay, now for these textures to be applied to our combined mesh, what you can do, uh, going the easy way, we can just copy these the AV coordinates of the individual meshes to our combined mesh, but that will work given that all the textures that we have in our in applied to our different models are in the same texture atlas. So if that is the case for you, then you can just go ahead and copy the AV coordinates like we did in the vertex, if did for the vertex and triangle array. That will work. But okay, now if you have different textures for these different models, then what you can do using the C sharp script only, you can combine these individual textures to a texture atlas, and then accordingly calculate the new UV coordinates for these individual vertices. In the part 2 of this video, I will show you how you can do that in using C sharp. So I will not be creating a texture atlas in Photoshop or externally. I will be creating the texture atlas using C sharp script. Okay, thank you for watching. So don't forget to subscribe, and if you find this video useful, like and feel free to comment. I will see you in the next video.